Hi, we're going to talk about how to figure out pH today, okay? And to understand pH, let's take a look at a very simple reactions. And the reaction is basically water. So if you take water and you basically react water with itself, so you have two molecules of water, typically ends up being one of these molecules acts as an acid and the other acts as a base. So then if this molecule of water acts as an acid, it releases a proton. So and if this acts as a base, it picks up the proton. So on the right hand side, you end up getting H3O plus, which is basically this molecule that picked up the proton from this acid. Okay. And then what's left over from this acid is the OH minus, the conjugate base. So now if you simplify this, okay, you could also write this equation as simply one molecule of water losing a proton and then generating its conjugate base. So either way you look at it, you're going to form a positively charged species and then a negatively charged species. And the positively charged species can either be written as a proton in the form of a proton, okay? And if you want to write it in the presence of water, then there's your hydronium ion, okay? So now you have that species out there, and then on the other hand you have this species out here, which is the same in both cases, and that's your hydroxide ion. So it turns out if you measure the concentration of your H plus or your H3O plus and the concentration of your OH minus, you find out the concentration in both cases for pure water turns out to be 1.0 times 10 to the negative 7 moles per liter. And in actually, let me just erase the moles per liter out here and rewrite the 7 a little better. 10 to the negative 7. And on the for the OH minus, it also ends up being 1.0 times 10 to the negative 7. And of course, since it's concentration, in both cases, it's moles per liter. And this concentration can also be expressed in short form as, I'm just going to slide up a little bit, as delta H plus, which is the same, not delta H plus, sorry, expressed as square bracket H plus, you close the square bracket, and out here, the square bracket out here is basically, it means concentration in moles per liter, okay? So you can write concentration in moles per liter of H plus is equal to 1.0 times 10 to the negative 7. Likewise, if you go back up here, you see how you have the H3O plus out here. So therefore, you could rewrite this as concentration of H3O plus in moles per liter is 1.0 times 10 to the negative 7. And then you can do the exact same thing for OH minus. Concentration of OH minus ions is equal to 1.0 times 10 to the negative 7. Now, as you can see from the concentrations that we've written down out here, these numbers are, kind of a little complicated because, you have a number out here, 1.0, and then you have a certain power of 10, and it makes this kind of a little hard to read. So in chemistry, what we tend to do is to simplify these numbers, we find a way to express these exponents only, okay, as a simpler number. And for that, just write that down here to find, or rather, to express exponents only, we use a mathematical function. Now, you don't need to worry what the mathematical function is. You just need to know how to use it, okay? And the mathematical function is log, Okay. So if you apply this function, and most scientific calculators have this function embedded in them. So all you got to do is, in your calculator, you take negative log of 1.0 times 10 to the negative 7, or simply just take the log, forget the negative sign for now. Log of 1.0 times 10 to the negative 7 in your calculator will give you a negative 7. So literally what happened was, I'm going to just use a different color out here. So that negative 7 is what ends up being your answer. That exponent is what ends up being your answer, okay? And kind of going back to this, since we don't really like negative numbers, you can just put a negative sign before the log, and then your answer basically gets changed to a positive 7, okay? So therefore, the negative log of 1 times 10 to the negative 7 is positive 7. And as you can see, if we that's basically the same as negative log of the H plus ion concentration, which is the same as the negative log of the H3O plus ion concentration, as you can see them out here, which is the same as the negative log of the OH minus ion concentration out there. See, out there. So therefore, uh, when we talk about pH, how does this all make sense from a pH standpoint? Well, then pH is basically equal to, this entire term simplifies to pH, and that's the same as this one. Whether it's H plus or H3O plus, it's pH, okay? And then the OH minus, since you're taking the negative log of OH minus, it becomes POH. As you can see, use a different color again. Because we're taking the negative log of the H plus ion concentration, that becomes pH. Negative log of the H3O plus ion concentration, again, it's the H that makes the H3O plus, therefore pH again. And then negative log of the OH minus ion concentration makes the POH. So, long story short, we can write this as pH is equal to negative log of 1.0 times 10 to the negative 7, which is 7. And this applies for water, okay? Likewise, POH is equal to negative log of 1.0 times 10 to the negative 7, which is again equal to 7, and that's for water again. So therefore, we can say that pH plus POH is equal to 7 plus 7 is equal to 14. And so if you're measuring, the pH or POH for anything in water, then the sum of the pH plus POH always equals to 14. And this is an important relationship. So we can simply write this as pH plus POH is equal to 14. And I'm going to just box this because this is a relationship which is used to solve many different types of numerical problems. Okay. With that being said, we're